and you can do better than bug reports, and that's a little bit tongue-in-cheek. I'm going to talk about diagnostics in Android and actually like what can you build up out of the tools in Android to really support an AOSP device in the world through the whole life cycle of dev, test, and production. And I guess in terms of an agenda, this is my first time being at this meetup, and I'm excited because I want to come to this going forward. I'm actually part of the group of the Google Android development group meetup in the Boston, Massachusetts area where I live. And especially in virtual meetups, I love going to technical meetups and meeting people. And I know in the virtualization, it's tough. So one of my goals today was to introduce myself and hopefully get to meet some of you one-on-one afterwards. And then to review the latest in diagnostics and debugging tools. So I assume a lot of you here are very expert, longtime users of Android, and a lot of it will probably be, oh yeah, that's been here since 2007. But what I tried to do is bring both, a refresher for new people, as well as what the latest and greatest of these tools are. What are the developments in 2022, things like that. And then get into what you can do with these tools and what I suggest you do in your organization if you're building a product, how to structure these tools together and build a debugging system that's better than anything that's out there. And then I'd love to learn a little bit more from you. I will talk about my background in a moment and my company's background, but I don't profess to know everything there is about Android. I'll talk about my background in a moment, but I'm hoping to learn about tools I don't know about yet and what's needed for you guys to do better with AOSP and AAOS. And then I'll talk a little bit at the end about Memfault and really see if you're interested in any future deeper dive into the stuff we're doing. So my name's Devin. I actually run our partnerships group at Memfault, but I'm a engineer that's been corrupted and gone over to the business and sales side a little bit. I think inside my heart, I'm still a benchmarking, scripting, dashboarding, and data geek. I now do that a lot with our sales team, but my background has started with master's in computer engineering. I guess to build my street cred in sort of engineering world, I had the totally thrilling master's thesis on floating point precision of NVIDIA GPUs and parallelizing medical algorithms and the differences between an Intel CPU and GPU in terms of the results in your floating point values. And I went from that to a little bit more interesting place, which was the defense industry in the US. And I worked at a commercial computer systems company that built embedded rugged systems for things like drones, like the EOIR camera ball systems on drones. And we put those GPUs and soldered them down onto boards and turned them into embedded real-time systems for radar and signal processing. And sort of my hobbies outside of my career were also embedded focused, really in consumer technology and IoT in the smart home space, really into smart home. My house is, at any moment, my house is either very smart or completely non-functional because of my hobby. But yeah, so love to talk about that stuff. Worked at a couple other companies maybe you heard of, like Permabit, which is actually in a startup that got acquired is now part of Red Hat and their block storage system. We did deduplication for high performance flash storage. And I worked with Wind River with real-time operating systems like VxWorks, again, in the defense industry, and now Memfault, which you'll learn a little bit about here. So Memfault is a team of guys and gals from the companies you see here on the left and many more, but really a team of engineers that built products. Number one, like our founding team was from the original engineering team at Pebble, so the original smartwatch. Maybe some of you are followers and lovers of that product before it got acquired by Fitbit, where they also worked. And we've come together to do interesting things to the embedded world, use that expertise. And we still actually try to just build, basically, I call it the Reddit of the embedded world. When I look around Reddit for like embedded topics, it's a little bit weak. On the interrupt.memfault.com page, It's really not a marketing blog per se. It's a community of talking about the latest SDKs and how to build better devices and things like that. So that's the company I work for, and my background lent good to joining this team. So what I wanted to talk about first, as I mentioned before, was a diagnostic overview, what's old, what's new, what are all the tools available, and hopefully you can let me know if I'm missing anything major. So real basic stuff first. Hopefully a lot of you know about the Android logging system. So that's the diagram in the upper right. And as you may know, basically there's like all your apps, your system processes and all of this running. And then there's a pretty good structure of a kernel space circular log buffers for various types of events going on. They're all aggregated. And there's a couple tools like Logcat and ADB, which help you basically extract those logs out to be able to use them for, like I said, diagnostics, performance monitoring, anything like this, either locally or from a host like with ADB. So Logcat, hopefully you know about this, like main system and crash. Those are the types of logs that are dumped if you just use Logcat without any special options. The other two, radio and event, are logs that you get if you use the all command or additional specifics with the tool. Interesting note is, if any of you haven't watched the stuff this year from the Android Studio Dolphin launch, they call it the biggest update to Logcat ever, which is a little bit I don't know, a little bit funny to me. Like, I guess in the world of logs and Logcat, how big can an update be? It is mostly a visual update to the Logcat system in the Android Studio, but it's pretty cool. There's a snapshot in the lower right here, which is kind of everything new all squeezed into one picture. But basically within Android Studio, there's now like more color coding and quickly able to see the different levels of Logcat log, like the debug warning information, those colored blocks there. You can kind of toggle on and off the columns of data that are within the logs. So you can like turn off the date or the time or the activity of the process if you want to shrink things down. And then you can split the thing and look at two Logcats at the same time. And then since I think to cater to, I'm a geriatric millennial, but to the kids these days who love the Google, Omni search kind of environment, they added this Omni filter text bar to be able to filter in any way with special commands through this one text field. So check that out if you haven't. And in all of these slides, I tried to put together all the resources that I've sort of viewed over the last year or so. And if you're like me, a lot of my learning happens on the Peloton. So I put a few YouTube links as well as readable links. The YouTube is where I learn on the Peloton a lot. Other logs to think about though are the K-message logs. So getting those from dmessage, those are great for capturing data after a reboot that may not be existing in the Logcat output. And one that also people miss sometimes are SE Linux violations and logs. Those are now included in the event logs that you get out of Logcat, labeled as AVC, but in older versions of Android AOSP, they weren't included there, and they were in like the audit log. For the helpful resources here, just a couple like direct out of Android guides, the first couple, but then a nice little third party deeper dive into the log analysis in Android, and then a couple of videos of the Logcat v2 features if you want to see a visual. So then I'm capturing here like more debug related tools than just logs. I mean, logs won't be used for diagnostics for the large part, but then what are some more tools around that system to help us process the logs, get them? So we all know ADB, that's like 2007 stuff, right? But that's your development host. You can get to your logs from Logcat remotely and do a bunch of other stuff like updates and things like that. Latest news there is in Android 12. Actually, this is a comment about most of Android's logging systems, especially when you try to use this stuff once a device is out in the world with a customer or something like that, is Privacy is a big issue. In test lab, when you're grabbing logs off a system, doesn't matter if you capture the browser history, the photos in the photo directory, stuff like that. But a lot of people are just sending devices out to customers, and then when a problem happens, saying, hey, run a full bug report and send it to me. And then next thing you know, their CSO wakes up or their CIO wakes up and it's like, oh, why are there like someone's cat photos in this directory? It's like, oh yeah, we've been grabbing bug reports for a year. And then everybody freaks out. So to that point, in the ADB backup command in Android 12, they've done things like excluding app data unless you specify it. So that could catch you if you're not realizing that till after you run an overnight test. Bug reports, that's like still the way that I work with a lot of companies that build products, and that's still the dominant way to capture information, so you don't have to talk to the person using the device or whatnot to get all of the information off. And it basically just captures all of the logs in the system and dumps them into one place, a snapshot point in time with the dump system state and logcat. Something better, if you're doing stuff out in the real world and in production environments or offsite, trying not to impact the device, is Dropbox Manager. That kind of gives you more targeted reports with data specifically from apps that crash rather than just a shotgun approach to the whole system. You definitely want bug reports if you can get them, because you can get everything, and then you have to get good at how quickly you can get to find the important data. But Dropbox Manager APIs in Android will help you if you can't store the bug reports, you want to just get more relevant information at a lower overhead. In terms of helpful resources, so a couple more Android links that are very basic. This Android bug reports videos, YouTube. It's only like a few hundred views on this person's page. This woman Dimple that put out some a bunch of Android tutorials on YouTube, but it's actually pretty good for walking through all the things that exist within bug reports and things like that. This is old, but if you look on the lower left, the picture here is actually other than like things in Android Studio, a bug report viewer that's free that exists out there is this Check Bug Report. I mean, it's been around since 2015, so you probably have seen it, but it's kind of funny. It's from the Sony Xperia. If you remember Sony Xperia developers, they built this internally and open sourced it. So it has some nice little like graphics for your memory space that's being reported and free and available memory, and just kind of gives you a web viewer for your bug report to make it easier to look through. Now, once you have logs and you have ways to capture logs and all the bundles of them, the next place that is interesting is thinking about all of the diagnostics information. This is probably, if you built devices, you've probably seen all of them, but tombstones are basically more detail than you get from Logcat about a crashed application. You know, includes the full stack traces memory map, open file descriptors, things of that nature. Application not responding information, I'm sure you're very familiar with those. Kernel oops are slightly interesting. I mean, you can get these out of the Logcat, but kernel oops are pretty serious kernel errors, but they're not always fatal. So sometimes people forget to look for those, because a lot of people look for, oh, when did my device crash and reset and things like that. But these can be helpful to think about. Java exceptions, now we're getting to more definitely app world of the Java exceptions, and there's a bunch of tools to look at those. And don't forget your SE Linux policy violations that we talked about earlier. Helpful link here also just going into how to use all of these more effectively. Images were mostly for fun here. So I'm not going to dive into Android Studio. I think there's plenty of stuff out there in that. You probably use it every day, but obviously in terms of visualization tools overall to like take all of this information and process it, do live debugging of your device, Android Studio is pretty amazing. Helpful links here actually in the last couple of years, some of these debugging tips and tricks, the new stuff that's in the Android Studio. I say new, 2019, it's like the pandemic, I feel like everything from like the pandemic is condensed to like maybe nobody looked at anything since 2019, but maybe you're well aware. There's cool new stuff like the groupings you can do with breakpoints, some of the ability to like go backwards and go back to a conditional statement and replay if you accidentally made the wrong choice, like jump out statements, kind of things like that are useful here. Another visualization tool for the data is Batterystats and Battery Historian. These are pretty cool. They basically take the battery information that's in the logs and then a bunch of other information and overlay it so you can see the battery drain from things. A little bit bummer though, like I think the last check-in on the project is like 2017. It's cool. People still use it all the time and it's useful. It's a little limited in terms of like going back in time and things like that, but definitely check that out. So as far as I know, my team, for the most part, before you get to like these big, cloud platforms and commercial tools, this is my overview and summary of what exists in logs. I'd love to know from anybody who wants to speak up and let me know, like, what's a cool tool for diagnostics that I didn't talk about yet? Did I miss anything? What would make me personally better on my Android IoT at home projects? Did I miss anything, Chris?
I'd be fair, not so far. I'm just going through my list internally. I'll come back to you in a moment. Anybody else out there have some thoughts on what Devon should be doing?
Jürgen unmuted, but we don't hear you if you're speaking. All right, maybe it was by accident. Oh, you're gonna get one now. You definitely want to talk.
No. Yeah, it's all what you said. Definitely, we are using Logcat all the way and looking about ADB bug reports. That's my daily business. I cannot say anything more about that.
Okay, cool. So great. So I think I caught a lot of it. Oh, Chris, you got one?
No, well, I was going to say that you could also mention interactive debugging using GDB or LLDB, which is what Jürgen's going to be talking about shortly, of course. So for that, you kind of have to know what the bug is, or you at least know in detail where you're going to be looking.
Yeah, that's a really good point, Chris, and kind of where I'm going here is that a lot of this is you have the device with you still in early development. It's a single device and someone told you there's a problem, your test caught a problem, and now you're looking into it. What I wanted to talk a little bit today was about building sorry, Chris, did you have a question?
No, go ahead.
Okay. How to build out of all of these tools, what actually the people I work with when they were working at Pebble, they kind of created something a lot cooler out of this. All of these tools to actually be useful to help find bugs, to help diagnose problems at a lighter weight, have real-time information, not have to talk to customers, all of these things. And I wanted to help you be able to do a similar thing. So what do we need to build on top of all of these tools are kind of a few things. Like we have all those tools in AOSP we just talked about. We have some agents like Logcat and ADB, but super useful if we can build better backends to get data, to database it, to help us organize the data, and then dashboard data so that we can do more than just debugging, but also this monitoring piece, which is kind of before it, unless you like waiting for customers to call you on Saturday, Christmas Eve, middle of the night. So to that point, you kind of want to build all of those things. And then of course you need to be able to update your device wherever it is, whether it's in your test lab or in the field, or and be able to complete a cycle of monitoring your new firmware and things like that. So what I'm trying to offer you is some assistance in like how to build a really cool thing internally, talk about what the Pebble team built, which is kind of on a few metrics of this monitoring, debugging, the logs and crashes, as well as system updates. And these are all the tools and a couple more in the update space. I didn't really want to talk about that today, but all the tools we talked about and where they exist in terms of like having capabilities and some of the tools that are available for dashboarding the data. So this is kind of what exists, but as you'll notice, there's not really a ton of connectivity all the way up or down the stack as I was talking about. I'm not going to walk all through these things. I'll pick on a couple of them, but this is what I would suggest to you if you're ambitious in your company to try to build up some of these pieces to be successful, is like an agent that's more than just the logcat and the ADB, that allows you to catch some like custom metrics, be able to run full time while the device is running, and be able to capture what's interesting from the logs and be able to automatically report them rather than thinking of it as like on your development host sort of process. And be able to get the logs basically in real time as things happen continuously on your device. The agent on the device, you'll probably want to be scrubbing for that personal information I talked about, able to tune up and down rate limiting for information coming from crashes, especially if it's like an LTE connected device, and things of that nature. On the back end, like on cloud connectivity side, thinking about like how do you optimize the data you're capturing, the transport over the internet, hopefully back to your dashboards, be able to process that data more on the server side than on the device, so you don't overwhelm devices while they're trying to actually perform functions. And then on dashboarding, on top of the tools like Grafana and Sentry and Battery Historian, there's a lot you should think about. I would say the major themes are like, do you have a strong alerting system coming off of your logs that are being collected so that you don't have to search for your problems and they're told to you? How do you understand if 50 devices in test or 100 devices in the field are experiencing the same problem or different problems? Like, can you aggregate and analyze things with an automated system? These are all things that if you want to like be a superstar in your organization and be able to not work on the weekends diving through bug reports, this is what I mean by like you can do better than just bug reports everywhere in your product lifecycle. Timing wise, I'm going to skip this real quick, but very briefly on Memfault, I think I only have a couple minutes left, right, Chris?
Yes, and we'd like to have a bit of time for a discussion of this afterwards. So yeah, go ahead.
No problem. So what Memfault is basically that what we built, my team built at Pebble and Fitbit, as well as Oculus and a couple of other companies, that infrastructure, all those pieces built up together and offered in an off-the-shelf product. So whether you build it internally or you'd like to get started quicker with an off-the-shelf tool, that's what we're doing at Memfault. And the purpose here of the diagram is it kind of completes that iterative cycle, the DevOps Infinity logo you see from the server world, to where you get in dev and test and in production monitoring and full debugging capabilities, as well as updating capabilities. And we're trying to do this from our perspective was coming from companies like Pebble, like even below Android embedded devices, but MCUs with real-time operating systems and bare metal. How do you do this stuff? But also now Android and Linux, any type of embedded device. We do come from the perspective of IoT devices, less than mobile handsets. However, we have tablets and mobile handsets supported as well. Like it's really just about IoT devices. And the idea is that of that table I showed you earlier, we have basically solutions for all of those things that work out of the box, and even some free access to this as well available, which I'll talk about. But what it kind of looks like in Android is starting on the far right and working left is that the components of those blocks are, I'll describe a couple of them here. Basically, we've replaced bug report. Well, we support bug reports. However, we've also designed Memfault Caliper, which replaces bug reports and allows you to capture the relevant information that would come in a bug report at a light enough weight way and a low overhead way that you can use it in real time on your in-field sensors and devices. fitness equipment, whatever. And then a series of apps at different privilege layers, basically to be able to configure and control and separate any updates. Like we don't like to update the kernel level, and then we want to have varied levels of permission apps for configuration and then for transmitting data. And then we built a cloud front end, a cloud platform front end that displays all of the information in real time, remotely in a web browser. So it's a collaborative environment. And what I'll real quick just give you a sneak, just a quick splash of what it really is. The ratio is probably not great here, but is this visible on your screen, Chris? Okay.
Yes, just about. It's fine.
Let me do one thing. This will be real quick. I will share just the screen. So in Memfault, what it actually looks like is
That's better.
Great. All of our devices, basically the agent reports up information from our devices over really any connectivity. We don't actually define a connectivity stack. The agent allows you to send the data over whatever you're directly to the internet or over Bluetooth, whatever you want. But you see devices with their serial number, their software they're running, their hardware, when they were last seen. So you get a little nice device registry. If we look at one of these devices, like this one, basically we have a nice UI and visibility into all of the things that are coming out of logs. Like you see logs, Dropbox manager entries, all of these things, which we call traces. This device is reporting these things up 21 hours ago. We have the system attributes, which you can get out of like bug reports and things like that. All the log files, so you could download them and look at them in Android Studio if you want, like kind of a log management. And if you click into these without going into Android Studio, staying in the browser, you don't have to have anything installed on your PC. You can kind of do the same sort of viewer that you would get in Android Studio of the logs, including things like your kernel logs and things that don't just come out of Logcat, and filter and do all of the same things. Reboot reasons is something we capture. So like all the reasons the device rebooted, which could be okay things like user reset it, but it could also be crashes and things of that nature. Bug reports, I'll go back to this in a moment, but we have a timeline view here, which includes something pretty cool, which if you remember the battery history viewer, this looks familiar to you, where here's like a new and better version of Battery Historian, right? Where you have your battery level, all of the other statistics coming out of the system. And you can, zoom into a time period. You can go back weeks if you need to, if you have that data. But on top of it, you also have an overlay of a timeline of system events that you want to track, when devices were rebooted, when crashes happened, things of that nature. One more thing, different device. If you still love your bug reports and you want to capture bug reports, we also have the ability here. I guess I might be on the wrong device. The ability here to capture a bug report, and you can skip through. You can look at the different views of all the data, kind of like that check bug report app that I showed you earlier. Now, that's all cool. That's like individual devices. Last thing I'll show today, and if you want me to come back and do something more, I'll show you, but kind of the more powerful thing that you can build or you can use Memfault for is aggregation of all of that data and analysis of that data. So what we have in our dashboards is like, here's all the devices that reported in that I showed you on the other panel. But here's all of the devices' total traces that each device I showed you on their page are reporting. And then we actually open up and analyze all of the traces and break down, not just like filter on a oops or an exception, but what problem was within all of the logs and get a signature and deduplicate all the problems so you can see 20 of your devices hit the same kernel oops while 16 hit a native problem here and a different native problem for 14 devices. And you can quickly, at thousands of device scale, figure out what the heck went on last night and find the issues. You can see the reboot reasons. And even further, if you drop into one of these, you can get a view of the stack trace for that issue right away. You can jump back and forth between different devices. This is all captured live on a system that was our SDK, our apps are light enough weight to run in real time with a real customer. And of course, it's in a web browser, so you can comment to your teammates, you can resolve issues, use it as a history tracking thing. Way more in here. There's aggregated metrics too, where you can aggregate all of the performance metrics to get like average battery life compared across things. I'm going to save that for another time or one-on-ones if you're interested, but getting very quickly, just last slide of closing off here. We do this for the same interface for actually AOSP as well as embedded Linux and MCUs, like real-time operating systems and bare metal, so you can have all your projects in one. Skipping over this, check out, if you want to learn like deeper level and everything I presented in 15 minutes, a lot of it comes out of these 2 webinars that our team did, which go into detail of like the tools that exist and not just our tool, but all of the tools. So I'll send these slides around, but our website, our SDK, our docs are all on here. You can try a free trial and use our platform for some of your hobby projects for free. And feel free to reach out to me. Excited to join the team and learn more from you guys.